Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the optimization of dual cycle. The thermal efficiency of the dual cycle is checking the area formed by the passes. It varies with the compression ratio operating in the temperature limits. The area represents the net work output for a dual cycle. For the fixed unit temperature T1 and the fixed combustion temperature T3, the net work output per cycle increases with the compression ratio, reaches a maximum, and then starts to decrease. From the variation, we conclude there should be a compromise between the compression ratio and the net work output for a cycle. With net work output per cycle, a larger mass flow rate is needed to maintain the same expected power output, which may not be economical, especially for the vehicles. With the change of the compression ratio, there must exist maximum specific network per cycle between T1 and T3. The compression ratio at this case is called the optimum compression ratio. For the thermal efficiency, generally, it increases with the compression ratio, and its limitation is the efficiency of Kala cycle working between T1 and T3. When the thermal efficiency is close to its limit, the Kala cycle efficiency, the specific network per cycle will be close to zero, corresponding to very large compression ratio. Obviously, this condition is not expected for the movable power system. The cyclic specific network, by definition, then is the first order and then the second order derivatives of the cyclic specific network then are. This implies the cyclic specific network has indeed maximum value at T2 and then the compression ratio, which could be found when the first order derivative is set to zero. The optimum end compression temperature and end expansion temperature are the optimal compression ratio corresponding to the maximum cyclic specific work is the dimensionless maximum cyclic specific network is the optimum thermal efficiency is the optimum mean effective pressure is. If the compression ratio epsilon is constant, the increase of the pressure ratio lambda and the decrease of the cutoff ratio rho, meaning that the combustion carries out more at isobaric process and less at isobaric process, can improve the thermal efficiency of the dual cycle. Now, I have two questions for you. Do you have any opinion about the cyclic specific network of a dual cycle? In analogy to the maximum specific cycle network, do you have any opinion about the maximum MEP of a dual cycle? Okay, That's all for this task. Thank you very much and see you next time.